Welcome to Online Algebra, starting with Lesson 84, Identifying Quadratic Equations. Know the form. Quadratic equations have a particular form. f of x equals ax squared plus bx plus c. These are written in descending order of the exponential power. A, b, and c are numbers. Ax squared is called the quadratic term because it has a square. B is a linear term because it's x to the first power, and c is the constant term because it's just a number. Okay? Always remember that when you start doing this stuff, to write it in descending order, and understand that a, b, and c are numbers, but a cannot be 0. Why? Because if a is 0, the x squared goes away, and it's not a quadratic function anymore. If you don't have a squared term, it's not quadratic. Right? So this is the particular form, f of x, or we know that f of x is the same thing as y. Right? X is the inputs, f of x are the output that you get. First task in this lesson is to identify whether or not you're looking at a quadratic function. In other words, you're to determine yes or no, this is a quadratic function or not. Remember that to be a quadratic function, it must have a squared term. Right? Not a term to the third power, not a term to the fourth power, but only a squared term. And also remember that a cannot be 0 because that would eliminate the squared term and you wouldn't have a quadratic function then. So you'll see amazing things like this. Y plus 7x equals 4x squared minus 6. The question is that a quadratic function or not? Well, you take what you're given and put it in standard form. In this case, we simply subtracted 7x from both sides, leaving y all by itself, and then wrote it in descending order, and we see that we have 4x squared minus 7x minus 6. And looking at this, you would say, what? Yes or no? Is that a quadratic function? And you're correct. It is a quadratic function because of the x squared term. What about these two? Look at number 2. Y equals 5x plus 2. Is that a quadratic function or not? No, it is not. It is not because x is to the first power. It's not squared. So you would say here, no, that is not a quadratic function. Take a look at number 3. Minus 2x to the third plus y equals minus 5x to the third plus x squared. Be careful. It does have a squared term, but it also has a term to the third power. That is not a quadratic equation. In fact, equations to the third power are called cubic equations. Yeah, which we will maybe not get to or get to later on. But the idea is if it's got something to the third power, it is not quadratic. Right? Everybody got that? Good. All right, let's take a look at your next task, which would be to graph quadratic equations. All right? Now there's a certain thing you can immediately tell about the graph of a quadratic equation. And first of all, the graph of any quadratic equation. Remember when you said, yes, this is a quadratic equation, then it's always going to look alike. And it's going to make this thing called a parabola. And the parabola, this curve, can either open upward or downward. And that all depends on the letter A that's in front of x. Whatever's in front of x. Simply put, if A is positive, then it's going to open upward. For example, y equals x squared, considered the simplest parent function of a parabola. If y equals x squared, A is equal to 1. Remember, we don't write 1, but it's still there. So this says that the parabola y equals x squared will open upward. On the other hand, if A is negative, y equals minus x squared, a equals minus 1, then it will open downward. All depends on just whether a is positive or negative. Doesn't matter how big or how small a is. Could be a fraction, could be a decimal, could be large or small. It just matters whether it's positive, it opens up. If a is negative, it opens down. Now using that, you can now take the next step, which will be to graph parabolas. And graphing you would do with a solution set. So for example, you'd be asked to graph f of x equals 3x squared minus 1. Alright, 3x squared is a quadratic term, therefore you know you're dealing with a parabola, and the graph is going to look like a parabola. And you want to graph what that looks like, then what you want to do is create a solution set. Sign of the cross, x, y. Remember that x is the input. You choose what that is. Make it easy on yourself. Always start with 0. So if I say x is 0, I put that into the original equation. 3 times 0 squared minus 1. And the 3x squared goes away, and so when x is 0, y is minus 1. If x is 1, y is 2. If x is minus 1, y is 2. Remember that when you're creating a solution set for parabolas, you always want to have a positive and a negative value for x. These x and y values that fit this equation then can be made into ordered pairs. 0, minus 1, 1, 2, minus 1, 2. And those ordered pairs can be put on a graph. And you can sketch it out. 0, minus 1 down here, 1, 2 right there, minus 1, 2 right there. You got 3 dots, and you draw or sketch the curve between those dots. That is our introduction to quadratic equations, and I hope you enjoy practicing this. It will be task number 1, which you are asked to complete lesson 84. A to G and 7 to 12. Lesson 84, A to G, 7 to 12. Again, you're going to be getting 3 math lessons basically a week. You have a week to finish them all up and get them turned in. If you have questions on this, I will be having office hours Monday, Wednesday, Friday from 3 to 4:30 on Zoom. And those Zoom sign-ins will be available to you on RenWeb or by email. All right? Well, one down and a bunch more to go.